Hello, and welcome back to the second day of the Tech Accelerator Mastering Azure and AI Adoption event. I'm Uli Hohmann, Microsoft Corporate Vice President of Cloud and AI. In case you missed them, yesterday's sessions delivered the technical guidance and best practices to improve reliability, security, and efficiency in your Azure and AI projects. Microsoft and AMD experts covered how best to govern, manage, and secure your AI deployments, how to achieve secure migration, and how to best leverage AMD infrastructure on Azure. Today's sessions will focus on how to build and modernize secure and reliable AI applications on Azure, the tools you need to design resiliency into Azure workloads and environments, and how to protect your Azure workloads from security threats. Thank you for joining. Let's get started.
Hello, everyone. This is Ben Brower. I'm just going to quickly go over some of the material that we were talking about yesterday and then hand it over to Rory and Joachim. So this particular title of this session is The Essentials to Build and Modernize AI Applications on Azure. So today we're going to talk a lot about the Well-Architected Framework as it relates to AI workloads. And we have two guests here, both Rory and Joachim, if you'd like to give a quick introduction.
Hi, my name is Rory Woods. I'm a cloud solution architect with Microsoft in the United States.
And I'm Joachim Ahlström, also cloud solution architect at Microsoft Sweden.
Great. Thank you, guys. Yes, it's going to be a great session. We have a lot of great content to go through. But what I wanted to do first is kind of remind everyone what we talked about yesterday in day one of this series. We talked about the cloud adoption framework and the AI adoption scenario. That was a pretty big area of new content that we made available in November of 2024. It was a pretty big announcement at Ignite, and it really helps customers realize how to adopt AI at scale. The purpose here is to help customers use landing zones specific to OpenAI, learn how to write policies that are specific to AI, and then, of course, how to adopt AI on Azure. So that session, hopefully you got a chance to see it. If not, there's definitely recordings to see. Today, we're going to talk primarily around the Well-Architected Framework and the AI workload guidance. Both Rory and Joachim have a lot of experience in this area. They've helped quite a bit in developing this content. There was about 100 people involved in developing the content. So as you'll see, it's very well done. I think it's very deep. And these are the two experts that you'll really get to learn from. And then finally, we have the Azure Architecture Center. There's a lot of really good guidance already available. Last year at Build, we announced the reference architecture for OpenAI. It's a GenAI chatbot reference architecture. It lends to and aligns to the Well-Architected Framework and this guidance specifically. And it also works well within the reference architecture for the Azure OpenAI landing zone. So with that, I'm going to hand it over to Rory, who's going to talk about the agenda and walk through some of the key elements of the Well-Architected Framework. So Rory, I'll hand it over to you.
Yeah, welcome everyone. Nice to be with you. Just a quick look at our agenda. We're going to back up a little bit and talk about the Well-Architected Framework as a whole, what it's trying to achieve, why it's useful to architects like yourselves. And then we are going to zoom in on that AI workload that we released. We'll talk about some of the design principles, the design methodology. We'll have a brief panel discussion where we talk about some of the intricacies of AI workloads. Why do we call out AI workloads? Why are there trade-offs when it comes to these pillars? And then the design areas will be a topic of discussion that will take some time, because this is where you're going to find those architectural decision points that you need to be aware of when you're designing your AI workloads. Finally, Joachim will help us with a demo of the assessment tool that helps step you through the design decisions you need to make when it comes to AI workloads. So let's take a minute. Let's talk about the Azure Well-Architected Framework. What is it? Why do you need it? The framework is a design structure that's trying to improve the quality of workloads running on Azure. Frankly, we found that customers that were deploying solutions to Azure didn't always accomplish the goals they were after. So it turns out just deploying solutions on the cloud doesn't mean you automatically get something that's well architected. The other realization was that some of the skills and tools that we used for on-prem solutions don't always translate. We needed to learn new skills when it came to designing solutions for the cloud. So we selected 5 pillars that help accomplish the goals that people are trying to achieve in these cloud solutions, whether it's being resilient, being as secure as you need to be, accomplishing the purpose and the objectives of your users within given timeframes. And you see those goals pictured here on the slide: reliability, security, cost optimization, operational excellence, and performance efficiency. Now, in the well-architected framework, or the WAF, you'll hear us call it sometimes, in that guidance, each of those pillars is broken down into design principles, some checklists that help you organize your thoughts around those pillars, recommendations that can be more specific, and then trade-offs, because you do have to find a way to balance across these pillars at times. With those pillars at the core of the well-architected framework, now we can kind of manifest that guidance, if you will, in things like workload design. For instance, the new AI workload, more specific, tailored guidance around a specific workload. We also have assessment tools, the Azure Advisor, which helps make recommendations to make sure you're always staying lined up with the well-architected framework. And then there's also some service guides on the well-architected framework. Now, these aren't a replacement for the documentation around Azure services, but they do help you understand how to configure Azure services through a well-architected lens. So it's important to get your mind wrapped around what is a workload in the context of the well-architected framework. What are we talking about? Well, this includes the application resources, the source code, if you will, the data required by that workload, and then the infrastructure that supports it. All of these things working together towards a defined business goal is what we would consider the workload. But it's not just the artifacts that you deploy. When we talk about workloads, we also think, how do we go about designing these? How do we operate them? What are the procedures that we need to make sure this workload is successful? So we already have a number of workloads defined in the well-architected framework. Sometimes it's the type of the workload, right? Is this an interactive workload? Is this a batch workload? So we can break that out, offer some well-defined guidance. Sometimes it's a particular Azure service that we find is best to take as a workload and offer some of that specific guidance, Azure Virtual Desktop, VMware services. And now we've gone ahead and established the AI workload as a specific called out workload that we can offer guidance around. One note that's important to remember when it comes to the well-architected framework is, while it's very, very important when you're designing a system up front, we do talk about it being a state, if you will, not a one and done activity. So we're looking to continuously improve. As these applications and workloads are implemented, we're learning new things. The cloud itself is innovating. We're getting new services and capabilities. So we're continuously considering where we are and how we measure up to the well-architected framework with our solutions. Let's turn our attention now to this AI workload that we've added. As you read this definition, I'm just going to call out a few of the key words here. First, you'll see we speak about predictive, discriminative, generative tasks. So while generative AI, or Gen AI, has gotten a lot of attention over the past year, the, if you will, traditional machine learning models are still very important. They provide a lot of value, and often they are the right choice, depending on the goal that you're after. So in the AI workload, we are trying to offer guidance that also includes those machine learning style workloads. You'll also see the word ethical here. That, I know as a software architect, is not something I needed to worry about much for prior work. But when it comes to AI workloads, it's something we do need to consider. So we try to cover some of that. You also see the word fast evolving. You know, I thought tech was already moving very fast and was hard to come up with until we got to AI workloads and discovered that that is very fast moving. We're talking about weeks and months. So that's going to affect our design, knowing that we're going to need to embrace that change and move along with it. As we take a look at the AI workload, you'll see that the guidance is broken up into design methodology, where we talk about how we do the work, some of those procedures, We'll talk about kind of recurring themes that you want to keep in mind as you're architecting them. We'll talk about design principles. That's where we take those pillars that are defined in the well-architected framework and apply them to the AI workload. And then the deep dive, the design areas, where we go step by step with some clear recommendations and discussion to help you make the right architectural decision points as you're designing these workloads. Let's talk for a moment about the design methodology. How do we get this work done? As you take a look at this slide, I'll just cover maybe one or two of these. We talk about having an experimental mindset. So what does that mean? Like we're throwing things against the wall? Well, no, we really want a data-driven, scientific, if you will, process to be able to make good decisions. What is the best model for our use case to use? Do we need to select from different embedding models? When it comes to breaking up a document or chunking it, if you will, for our knowledge retrieval systems, what's the best way to do that? What works best for our documents? So we're going to have to come at this system with a plan to be able to experiment and make data-driven decisions to get the outcomes we want. I'll also stress that last one, design for adaptability. As we said, these AI workloads and the AI tech space is fast moving, and we're just going to have to embrace it. We're going to have to go into it knowing that some of the very things that we implement will have a limited lifespan. We can't avoid it. And we're just going to need to figure out how to enable the ability to update our systems as we go to remain agile and flexible. I'll pick up just a few of these design principles. So here again, we're taking those WAF pillars and we're applying them to AI workloads. Under the reliability pillar, we'll discuss how to ensure model response is reliable and within the timeframes that we're expecting. Inference can be a bit of a black box when it comes to some of these large language models. So how do we make sure we're designing our systems to give responses back to the user in a way that they are timely and within the expected objective? Under security, we talk about content safety. As architects, we're very used to considering the data coming into our systems as unsafe and treating it accordingly. But now some of the data and information that we generate out of these large language models, we may need to consider unsafe. So how do we handle that and make sure that we're maintaining the security? Finally, in the operational excellence pillar, we talk about observability, and that's something that's always been important in our cloud solutions. But now we have some perhaps new metrics that we need to be looking for. How are we constantly making sure that the answers that we generate, the models that we're using are not drifting, are not decaying from those objectives that we set at the beginning? We may need even to involve users to help us to understand when some of the data that we're generating out of these AI models is no longer fit for purpose. So I encourage you to look at that guidance in those documentation. I guarantee you're going to learn something. We're now going to flip to our panel discussion, and Ben's going to lead us in that.
All right. So, Rory, I'm going to start with you, and Joachim, please chime in. One of the things that we think a lot about in the well-architected framework is just the kind of the general nature of the principles, how you can use the principles. So why do we have an AI workload? Why do we have something that's specific to AI in this case?
Yeah, it's a good question, Ben. I think we do need to acknowledge that a lot of the principles that we already apply in other solutions still matter here when it comes to AI workloads. We're still thinking about those things. But what we began to see is that AI workloads do have some unique behaviors and characteristics, which kind of demanded that we maybe get a little more specific when it comes to applying the pillars and principles of well-architected to them. I think, for one thing, they're non-deterministic in nature, and that's kind of new maybe for some of us architects and programmers. Typically, systems operate the way we design them. Now, of course, there's bugs and maybe some unexpected code paths, but for the most part, they're not emitting data that we didn't count on. But the reality is with these Gen AI models, we're getting data and inferred responses coming from those models that we didn't expect. So that means there's maybe new safety things we need to consider. There's ethics we need to consider, especially as we get to agents. If we're going to allow these LLMs to control flow paths, right? How do we make sure we're doing that safely, in a performant way, in a way we can observe and monitor? So we constantly need to be kind of in this evaluation loop. The reality also is that the AI tech landscape, as we mentioned earlier, is fast moving, really fast moving. So how do we make sure that we're taking, for instance, new model versions when they release, putting them through some evaluation, and then how do we get them into production?
Yeah, my reflections, Ben, you mentioned CAF earlier. And in a similar way that we have generic CAF landing zones and scenario-specific landing zones, such as the AI landing zones, it felt natural to collect best practices from customers and partners to have an AI-specific WAF guidance, how to design your architecture and solution for both discriminative AI, such as machine learning, deep learning, as Rory mentioned, and generative AI. And we wanted to bring guidance for the specifics, AI topics such as indexing, data drift, concept drift, MLOps, GenAOps, and DataOps and responsible AI all together. But of course, in relation to the WAF principles that Rory mentioned. And another differentiator that is very AI specific, like top of mind, is the compute and data handling. You have data to train or fine tune your models, and it may require big data processing for machine learning. It might require large clusters to train a model, such as an LLM. Looking back at GPT-3, I think it had roughly 175 billion parameters, and it took 9 days to train using our Azure supercomputer, right? And compared to that, if I were to train GPT-3 on my laptop here, it wouldn't take 9 days. It would take roughly 665 years. So training is out of fashion, right? Now we fine tune or we create RAG solutions. We have vector databases for Gen AI, vector embeddings from text, which is specific in itself, right? It's a bit different compared to SQL compute to match an order with order detail for a web shop, right? Or to generate your fiscal report with a data warehouse. So we have recommendations around this, around the data for training and testing, compute for training and testing, when to use what compute in this guidance. And speaking about models, another thing that is specific is the models itself, right? Rory mentioned model decay, where we constantly need to monitor the solution because it constantly changes. The reality are shifting. So if the real world are changing, we can experience a concept drift, so we need to retrain and refit our models, right? So that's very specific compared to other guidances, I would say. So when should you refit your model, and how to optimize your vector database concerning indexes? And this actually leads us into another reason why we have the guidance. We spoke about trade-offs, design trade-offs we found unique for AI scenarios. So let's talk about that, Rory.
Yeah,
Trade-offs.
I was thinking about the same, Joachim. One of them, I think, in the app design area is co-location of resources. And we've always had to give that some thought in our systems, but maybe now more than ever, we're looking for ways to optimize those systems. I think especially when, that inference step where we maybe pass something off to a large language model, we don't have a lot of control over how quickly it responds. And here we are, we have interactive users. So we might be looking for ways to optimize everything we can around that LLM call. So now we have to figure out, right? Do we co-locate these things to lower the latency between some of our APIs and the LLM or our knowledge retrieval step? Maybe we're using small language models that we're hosting, right? Do we put those right on the same Kubernetes cluster with our API and our other app services to try to get that time squeezed down? But of course, then we need to think about the other side, right? Do we take on risk when it comes to reliability and resiliency by co-locating those resources? So sometimes with these trade-offs, the well-architected framework doesn't necessarily have an answer, but we can at least bring you the question, right? This is the decision point you need to make. Here's some of the trade-offs. Think it through. I know, Joachim, there's some others that are close to your heart.
Yeah, sure. Top of mind, I'm thinking about working with data. Again, when working with the AI solutions, sharing and duplicating data is a trade-off, right? It incurs cost to duplicate data, storage and compute cost. But if you follow the medallion concept, you will have a minimum of 3 files, right? You will have the bronze raw data, and then you will have a silver data file, which is very shareable and reusable across your organization. And you will end up with your gold specific file, which is very specific for your use case. It could even be extremely specific for a machine learning algorithm, not very shareable, right? So the trade-off here is, of course, You can go from bronze to gold directly to support your use case, not saving your silver data. Then you save some storage costs and some compute costs, but you will lose the ability to reuse your refined data, the silver data. So that's one top of mind trade-off. Another one is the grounding data when we talk about indexing for semantic search, right? Enabling capabilities to index fields such as filtering, search, it increases space requirements, right? And the trade-off here is that it affects cost, but it adds performance. So only add the capabilities you intend to use and consider both cost and performance. That's what we have in our guidance. We have multiple trade-off sections around each design area. There's also trade-offs speaking about roles and personas that I will talk about later as an example.
All right, thank you, Joachim. That was a great answer. A lot of information and thoughts around trade-offs and especially around data. So another question, when you think about like responsible AI, we hear a lot about responsible AI, trustworthy AI. That's a term that's been used a lot recently. Like what are some of the considerations that around responsible AI and how are they imbued within the well-architected framework?
Very good question, Ben. And this is an area that is dear to my heart, responsible AI. And our WAF guidance adheres to the Microsoft principles of responsible AI. Here we talk about fairness, transparency, inclusiveness, reliability and safety, privacy and security, and accountability. And we will cover this on its own in the design area, but looking at the WAF guidance, it provides recommendations that addresses each and every area. And responsible AI sort of goes across the other design areas also. We need to keep responsible AI in our minds all the time. How to design an AI system that is fair and inclusive. Essentially, all design area touches responsible AI, from application, data platform, operations, MLOps, and so forth. And in the guidance, we also address trade-offs, as we said, and provide recommendations related to these, such as the importance in MLOps and GenAIOps to include this, to have continuous evaluation of your AI models, to ensure that they are operating in a reliable and safe manner, to have metrics for responsible AI also to find out if there is any bias in the models, and the responses from an AI chatbot, speaking about GenAI. And we have tools how to mitigate it also, for the AI solution to be fair towards people. And how do we ensure that we don't introduce new bias if we have mitigated this already in one training iteration? Topics like that is covered in the guidance.
So thank you, Joachim, for that was a great answer around data gathering and management for trade-offs. It's a very interesting topic for sure. So one last question around responsible AI. Responsible AI, we talk a lot about responsible AI. We talk a lot about trustworthy AI. It's the kind of the newest term. And it's one of those areas that should be imbued everywhere, particularly in the well-architected framework. So, Joachim, what do you think? Where do you think the well-architected framework uses the responsible AI?
Thank you, man. That's a really good question. A question close to my heart, actually. Our guidance adheres to the Microsoft principles of responsible AI, such as fairness, transparency, inclusiveness, reliability and safety, privacy and security, and accountability. And the WAF AI guidance provides recommendations and addresses design considerations within these areas, such as how to design an AI system that is fair and inclusive. And we will cover this in its own design area later on. And essentially, all other design areas touches responsible AI, from application, data platform, operations, and MLOps. So in the guidance, we will look into the responsible AI perspective in other areas also, such as the importance in MLOps and GenAIOps to include continuous evaluation of the AI models and solution, ensuring that they operate in a reliable and safe manner, to also have the responsible AI metrics included to find out if there is any bias in the models or in the responses from the AI that we can mitigate. And we have tools for mitigation. We have tools for diagnosis for the AI solutions to be fair towards people. So how do we ensure that we don't introduce new bias if we have mitigated this one time already? Topics like that are included in the WAF AI guidance. And Rory, you mentioned a perspective to me earlier, right?
Yeah, I think there's an example that shows the knock-on effects of responsible AI considerations. In the responsible AI design area, one of our recommendations is keep AI decisions clear and understandable. So that may mean showing citations or showing the knowledge retrieval that was done. Well, that kind of flows back into your application design. How are you going to show this to the user? You might have to build a user experience that allows a user to see the citations or maybe to drill down to see the thought process of the inference step. So it shows how important it is to be considering responsible AI upfront so that you can account for those decision points throughout the many design areas that it will affect, like you were saying, Joachim.
Hey, thanks very much for that answer, Roy. It's a very interesting topic for sure. So let's go ahead and move on into design areas. And Roy, take it away.
Yeah, these are the design areas that we include in the AI workload. So each design area article begins with a table that kind of summarizes the recommendations. And then it's followed by some really detailed architectural decision points. The goal is to help you along to make those decisions as needed. It includes things like some tools that can help you along the way to make sure you're achieving the goals of the design area. And also the trade-offs, as you've heard us talk about a few times already in this session. You'll notice as we go through each design area in the upper right-hand corner of the slide, there may be a little icon of two opposing arrows. That indicates that there are trade-offs included in that design area, and we encourage you to take note of those as you look at them. We'll start with the application design. So again, when designing an application, any application, there's certainly things we need to think about, but we'll kind of focus on some of the specific AI considerations when it comes to our app design. One of the first ones you may need to make when it comes to AI workloads is whether you'll use your own model or use a pre-built model. Typically, the use case itself would drive that decision, but it does have some design considerations that need to be considered as you go on. And this article will kind of lay out some of the options and maybe help you think through that. Another decision point when it comes to application design is whether you're going to use an orchestrator or not. These have become very popular. They help manage the AI workflow that we see. Maybe it's knowledge retrieval and then an inference step, or maybe it's more of an agentic orchestration that's required. And these orchestrators coordinate that communication and those steps among the different components that are needed. And sometimes they're right for the solution that you're trying to build. Sometimes, frankly, it's easier just to use the API that's available from the model. So again, another decision point that we're going to try to help you come to the right decision for your solution. Another design area that will need your attention is the application platform that you're going to select. This guidance has been broken up into 3 sections, depending on the type of app platform you're building, or maybe you'll need all 3. There's an EDA platform or exploratory data and analysis. That's a tough one. The data scientists that are using this platform have very different needs from your end users. So what kind of a platform are you going to select to support the EDA process? How will you evaluate those tools? Next, model training and fine tuning. There are also another universe of tools and platforms that you can select from in Azure and elsewhere to make use of those models and fine tune them for your specific needs. And then, of course, the inferencing platform itself. Will you host your own models, perhaps on a Kubernetes cluster? Or will you use ones that are provided in a PaaS model? This will have effects on throttling, perhaps the regions you can operate in, since certain models or certain model versions may not be available in every region. I'm going to hand it back to Joachim. He's going to take us into our next design area, data platform.
Thank you, Rory. Yeah, data platform is the next design area. And data is the fuel for AI, right? And here you see the building blocks of the data needed in different situations. And DataOps is a key element in an AI platform. Looking at storage, how to handle large amounts and potentially many formats of data. Data used for inferencing, training, and the reusability around data. We also have processing recommendations around ingesting and transferring data, how to unify security and access, how to share refined data, governance, feature stores, vector stores. There's a lot to it here, speaking about AI. And if you're a multi-cloud customer, how to unify data without egress costs, and how to reduce latency associated with data copies and staging. Those type of recommendations we address within this design area. For Gen AI and RAG solutions, how to design reliable and relevant search indexes and how to store them efficiently. Questions such as, do you expect to store multiple versions of your data? And how to do partial upgrades of an index. This section is around those questions. Going further to data design, training. We have design strategies for data ingestion, pre-processing, retention, and governance topics to handle your model training data. And in the goal of avoiding bias, different techniques to use balanced data to get fair and accurate AI predictions, and who have access to what training data, speaking about retention of predictions and data at inference. Trade-offs here. Well, I mentioned earlier a trade-off between sharing refined data, which requires a duplicate of the silver data files. But there are other scenarios how we can avoid duplicating data, avoiding egress cost, avoid storage and compute cost. And if this is a topic on your table, this design area is for you. Looking further at the grounding data here, we also talk about strategies to optimize searchability and retrieval while meeting security and compliance requirements for your grounding data. So who have access to what index and what is the accuracy and how grounded are the answers? And in this section around grounding data, we also mentioned some trade-offs such as cost and performance. I mentioned that earlier, only add index capabilities that you intend to use. Another trade-off is you may want to use one large index which provides good performance, with filtering works great, but it works best with unified data. And the benefits here is that it provides easy management. The alternative for one large index is to use, of course, multiple smaller indexes, which provides great performance and works well with diverse data, with the downside, of course, that it will add overhead to manage them all. Going further to the design area operations here, in the guidance, we address topics such as the value and importance of monitoring all aspects of your workload. And you might need to use a gateway solution like Azure Application Gateway, Azure Front Door, API Management. And in this section, we talk about how you can share resources across AI workloads, such as Azure API Management with the AI Gateway add-on. With this, you can have a centralized shared Azure OpenAI PTU with a pay-as-you-go fallback. And you can also get support across your organization for a centralized service. We also speak about load balancing and deployment. And in the guidance, we have recommendations around this, such as blue-green deployment, canary deployment, when to use regional versus global load balancing. So that's the area operations. Going further to MLOps and GenAOps. Here we talk about how to establish a modern DevOps practice for AI to support your machine learning or generative AI functions and systems. End-to-end, from DataOps to MLOps, and further to monitoring with the outer loop, as we see here. We talk both about an inner loop versus outer loop in the guidance. So how do your team protect against model decay? What triggers should you act on? On code change, when data changes, or when the real world changes? When to refit your model and how to automate this? That's the topic for this section. We also speak about Gen AI hallucinations and evaluations. The importance here to have tools like we have in Azure for both batch evaluation and live monitoring of metrics in Azure, and how to go about to include responsible AI tools in your MLOps process and Gen AI process to identify model errors, to diagnose the reason, and mitigate unfairness or quality issues. We also have content safety filters. So when you have your Gen AI solution, you have metrics and attack detection for prompt injection, for instance. And here we focus on automation for model testing with metrics such as indirect and direct jailbreak detection. Metrics such as AOC accuracy for machine learning models to have them continuously automated tested going from dev stage to production. Speaking about testing, this leads us into the area of testing and validation. It's important to develop testing and evaluation strategies to measure characteristics such as accuracy, precision, or for Gen AI and RAG solutions, groundedness. And in this section, we go in depth around these metrics. Looking at this, at ingestion, during training, for your endpoints, such as load testing, we have metrics all the way testing and validation using orchestrators such as GitHub Actions or Azure DevOps pipelines. And here we talk about also red teaming to define success criteria for testing and validation, to have an end-to-end coverage from dataops to MLOps with evaluation to find model decay, data drift, concept drift, and to automate all of this with CI/CD and automated testing. Even code quality like the traditional WAF AI workloads, of course, is included here. And do we have any trade-offs here? Well, using large data to train and test on adds compute cost. So can you get good results with a smaller data set using a more qualitative approach? We provide strategies such as in the R&D phase, you can do initial testing on a subset of data to assess whether the model produces reasonable results, and then gradually you can scale up to the full data set. Responsible AI. Here we see the 6 Microsoft responsible AI principles, such as fairness. Our AI system shouldn't be discriminative against individuals or group. We should treat people equally. Transparency. How people understand or misuse or incorrectly estimate the capabilities of your AI system is important to be transparent and clear because the system should be understandable. Rory mentioned that in the application layer, you might have disclaimers that a chat is powered by AI, and you might provide a link to the source content of the response, speaking about RAG. Inclusiveness, empower and benefit diverse populations, ensure that all can take advantage of the AI that you build. Reliability and safety, ensuring that everything works as intended and do not cause harm. And then we have the 5th box here, privacy and security, to protect personal data. Anonymized data, scrub data, tools to remove PII information, work with classified data, the right to be forgotten. In the guidance, we address these areas. And the last but not least, accountability. How can we create oversight so that humans can be accountable and in control? And if you design right to include responsible AI tools in your DataOps pipeline, in your MLOps processes, you can identify the model errors, you can diagnose the reason and mitigate unfairness or quality issues. And you can use the content safety filters in real time to avoid sexual, hateful content and to have jailbreak protection and be safe. An example, training data can introduce bias for a model to treat people differently depending on gender, age, or other human characteristics. So how to avoid introducing new bias if you have mitigated it already? Working with synthetic training data or normalizing the data. Leverage feature stores with responsible AI tagging. Those type of things. And how to include continuous monitoring for responsible AI metrics and connect personas to act on the alerts from a metric. That leads us into the next section. Personas. I mentioned some benefits with personas earlier. Now let's look into how personas can be defined and connected. Here you see persona template cards. You have 4 persona template cards here. You can see which persona should have access to what services and tools, and you can define what skilling does a persona need. As you see here, we have links to Microsoft Learn. You can also see with persona cards how they are connected to an architecture and service and a process. Which persona should have access to what services and tools here, in what environment. If we look at the processes, DataOps, MLOps, and GenAOps to the left here, we have the environments dev, stage, and production. And the pink boxes represents a persona which is a build agent, not a human being. And in the stage and production environments, we want to have everything automated if we can. So that's where the build agents are acting, whereof the persona data scientist works in the dev environments and work with CI/CD to get the workload to production. So we see here that we can see how personas are connected both with the architecture, such as the Lambda architecture here, or the Gen AI architecture here. And we can see how they are connected to the processes. Let's bring an example scenario. If you have an urgent incident in production, who are you going to call? Well, not Ghostbusters maybe, but the relevant persona that owns the affected area. And the alert should be automatic and ping the personas. And debugging at inference often require multiple personas, all hands on deck almost. The app developer to analyze performance, is the endpoint experience heavy load, a data scientist persona to see, does the model need to be refitted? And we might have a security persona to watch the gateway to see, do we have any DDoS attacks or prompt injections going on here in the monitoring logs? To summarize, for your architecture, you can use personas to map skilling and educational needs, define responsibility in your architecture, define security and access to the services, and find resource gaps. So is there any trade-offs mentioned around personas? Well, if you have too few personas, it can make it difficult to implement role-based access control with least privileged access and to distribute work responsibilities effectively. Conversely, having too many personas adds management overhead. Now when we went through all the design areas, ending with the persona workload, let's look into how you can assess your AI workload towards these 10 areas. Let's look at a demo of our self-assessment tool for the WAF AI workload. This is a demo of the AI workload assessment tool for Azure Well-Architected Framework and the AI workload. What you see here is the landing page for Azure Well-Architected Framework. And you can find this by going to aka.ms/WAF. And if you click on workloads, you will find the AI workload and other workloads. So if you're familiar with the other workloads you see here, the structure looks pretty much the same. We have get started, design methodology, design principles, design areas, and the assessment landing page for the tool at the bottom. And it looks the same if you're used to working with other workloads such as Azure Virtual Desktop. You have get started, design principles, and assessment tool at the bottom. Let's jump into the AI workload and assessment tool. So here you see instructions around the assessment. So what is the assessment tool? It's a set of questions that are based on the AI workload design areas. It's a checklist with control statements. Who is suitable to do the assessment? Well, we recommend for the team to perform this to be well-versed in the architecture of your workload, but also have a strong understanding of cloud principles and patterns. We recommend for you to collaborate and have a diversity of roles and personas when you answer the questions. You can easily see which questions you have responded to and not, and it's all checkboxes. And if you're unsure of the statement here, I recommend to leave the checkbox unchecked, because in the end, you will get a scoring and recommendations where you can improve area gaps. An unchecked box will provide you a link to more information, best practices, and information around the area. Let's start the assessment tool. If you click here at the top, it will take you to the assessment tool. Make sure you're logged in, and here you also can find your previous sessions. I have 3 sessions, 1 is completed and 2 in progress. It takes roughly 30 minutes to do the assessment. You can click here, Start Assessment. But for this demo purpose, let's look at a completed session and the results. Here you can edit the assessment name, and you can create what we call new milestones. Because the idea is that you do these assessments continuously to see your improvement. Let's jump into this assessment. Here you can see all questions and your selected answers. You can click here to view the guidance. Here I see my overall result. And even though it's excellent, I can see that there's room of improvement in the areas of design your data platform, test and validate, create personas. And I can even export this as a CSV to share among colleagues. If I scroll down, we see all the areas, and even though it's green, we can see that we have recommended actions in design grounding data in this case. We see a link to determine which index fields should be searchable, filterable, and sortable. Let's jump into that. This takes us to the well-architected framework for the AI workload and the design area grounding data design. So we can learn more and improve our workload. That's how the result and recommended actions look like. Let's go back, go into an assessment in progress to showcase how you can elaborate when answering each question. The demo scenario is that I work at a company called Contoso, and we have an ongoing assessment here called Internal Enterprise RagChat and ML Models. Let's resume that. I know that we worked on these questions yesterday with my team, but we had some questions that we want to continue to do. And one of them is within the design area of training data. Design training data. How do you manage data collections and segmentation in an organization? When we use production data for training data, it's subject to the original data classification constraints of that data. Check on that. We have a data catalog which classifies the data. This will follow along. Second one, We retrain models only when we have new data to train on. Well, that's not entirely true for us. We retrain our model also when the code changes on the same data, and if monitoring shows that we have a concept drift, we need to act and refit the model. To segment our data, we use a method that complies with all relevant security and regulatory requirements. Check on that. We have access controls to ensure only authorized users can interact with specific data subsets. Yes, we have access control down to the ACL level using our data catalog Azure Purview. Check. Great. Any more questions? Here's a red asterisk. Incorporate MLOps and Gen AI Ops. What actions do you take to streamline how you operationalize AI models in your workload? When we train our own models, we create repeatable pipelines that can run common operational procedures. Yes, we have both DataOps pipelines with Azure Data Factory and Azure Machine Learning pipelines to retrain and redeploy our models. And speaking about Gen AI, whenever someone changes the RAG logic, CI/CD will redeploy the prompt flow and test the endpoint. So yes. Well, code base instead of UI. Yes. Speaking about prompt flow, we use FlexFlow to create our prompt flows to have a code-first approach. Our operational processes align with the application platform we use. Yeah, the application platform runs on top of GitHub and GitHub Actions. It's the same with our AI workflows. Check on that. We critically evaluated the set of tools, program languages, and platforms that we use in our process and made an effort to reduce complexity. Yes, we have a Python-first approach for the data scientists and developers, and we use the CLI when working in a DevOps fashion. And we use Azure AI Foundry to have a complete tool set and work in a uniform way, working with all of our AI workloads. And we have all of our AI workloads inside of our enterprise-scale AI factory. So yes. We use automated processes and tools to evaluate model performance on a regular basis and to ensure ongoing quality. Yes, we have templates for DataOps, MLOps, and GenAOps, and we use the workflow orchestrator GitHub Actions. As an example for machine learning deep learning, we have test sets scoring automatically calculated, and we have live monitoring with performance metrics and also responsible AI metrics. So we can detect data drift, concept drift, and tackle model decay. And the same goes for Gen AIOps, where we use the Azure AI Foundry SDK and the toolkit there to get live monitoring and to get continuous improvement of our workload. Responsible AI. What content safety measures do we implement? We use content moderation techniques. Yes, we use Azure AI Foundry and the content safety moderations for sexual, violent content, indirect, direct jailbreaks, etc. We use threat modeling. True, check on that. And we have metrics and processes in place to monitor the ethical behavior. Yes, we use Azure Machine Learning Responsible AI Dashboard and the scorecard. We have these embedded in our MLOps pipeline. Our workload regularly validates both incoming and outgoing data for content safety and compliance. Check on that. Last question. Create personas. How do you categorize and staff the various roles and responsibilities in relation to AI workloads? Great question. Our organization has defined workload team personas. Yes, we used persona cards to define our personas. Check. We regularly refer to workload persona definitions to ensure that we allocate roles and responsibilities correctly. Yes, we have connected each persona to the services in our architecture and also connected the personas to the processes of DataOps, MLOps, and Gen AIOps. Check on that. We create persona and governance controls based on the needs and requirements of each roles. We also connected each persona to what services they need access to, role-based access control. Our persona helps us define who does which task during an incident or an emergency. We have monitoring that will alert relevant personas to be able to act on the incident. We catalog all AI-specific workload personas alongside standard personas that are part of most workload teams. Yes, we have all the persona cards in the same catalog. All done, and we already looked at how our result and recommended actions look like. So that's it for this demo. Thank you for watching.
Thank you, Joachim, for that great demo of the assessment. It's going to be one of those great tools that we have for our architects who are looking to design workloads both before going into production and then looking at their choices and decisions once that workload's in production. So I think it's going to be super, super helpful. Also wanted to point to a couple of additional resources. I did talk a bit about this at the beginning of the presentation, but we have some great reference architectures that were published last year at Build. We also have some great guides that will help you design these workloads for your specific needs using RAG patterns and other sorts of proxy-based patterns. So definitely take a look in the Azure Architecture Center and look under OpenAI as your search keyword. And there you'll see probably between 20 and 30 different resources that you can then use. And then finally, wanted to give a quick shout out to the Azure Essentials brand. As we've been talking about throughout this series, Azure Essentials is going to be one of those key areas that you'll want to follow. And it's going to be one of those brands that is going to help in many different scenarios, not just with AI, but with SAP and migration and other important workloads that you have for adopting on Azure. So take a look. It will give you all the comprehensive resources in one place, so it makes it easy to find. There's going to be direct access to various experts such as Rory and Joachim. And then, of course, there's extensive coverage of various scenarios that I mentioned earlier. And so on behalf of Rory and Joachim, I want to thank you for attending this full session. Hopefully you got a lot out of it. And hopefully you get a chance to check out the well-architected framework for the AI workload. And now on to the next session. Thank you.